Hello, my name is Lukas Künzer, and today I'm presenting our paper Telling Us What You Experience: Effects of Questionnaire Interface Design on Subjective Measurements in Virtual Reality. Virtual reality as a research medium enables immersive, controlled experiments. But measuring user experience in virtual reality can be methodologically challenging. This work is a collaboration between multiple research teams who all independently developed in-VR questionnaire tools. We actually met at a conference, started discussing how we each solved the same problem in different ways, and then realized there's an opportunity here to learn from systematically comparing our design approaches and their effect on user experience and VR experiment robustness. That conversation became this paper. We carried out a study with 44 participants and 3 VR questionnaire interfaces. The tools differed in placement, interaction, and distance from the user. We will have a closer look at the station, watch, and board later. Participants used the 3 different questionnaire tools to rate their experience with the task and the overall virtual environment, but also their experience interacting with the respective questionnaire tool. What makes the study special is that it was not built around a single lab prototype. Instead, multiple research teams came together, each bringing a mature, already used in-VR questionnaire toolkit. All of us had deployed these tools in real studies. All of us had design rationales, but none of us had evaluated them head-to-head under controlled conditions. So rather than designing yet another interface, we asked a more fundamental methodological question. Does the interaction design of in-VR cues bias subjective responses? In VR research, we heavily rely on subjective measures when measuring user experience in simulated scenarios. Presence, workload, usability, flow. These are just some of our common core output variables. Employing questionnaires for participants to rate the experience is part of our standard way of working. The common practice is still to take participants out of VR, hand them a web form, a paper form, or a desktop questionnaire, and only then ask them to reflect. That creates a methodological problem. Leaving the virtual environment changes the measurement context. It interrupts immersion, introduces a break in presence, and increases reliance on memory rather than immediate experience. This can impact overall test quality and is especially awkward in repeated measure designs that require participants to go back and forth between VR and the real world for reporting. This is not only annoying when faced with refitting headsets, but can also increase the risk of cyber sickness. Prior work already suggests that in-VR questionnaires can help here. They let participants answer in context, immediately, and with less disruption. Participants report increased comfort and preference for in-VR questionnaires. Using in-VR questionnaires can help streamline study designs, particularly in repeated measure designs, and allow continuous in-context reporting. But here's the issue. Let's say we increasingly collect user experience measures inside VR using in-VR questionnaires. And yet, the interaction design of these tools can drastically vary. Different placements, different interaction metaphors, different embodiment levels. So the key question becomes, are we really measuring the experience, or are we partially measuring the interface we use to ask about that experience? We compare these 3 established 2D in-VR questionnaire tools that are available to researchers to use in their studies. The Rover Rating Station is a medium-distance, world-anchored panel operated with a raycast laser pointer. It emphasizes integration and ergonomics. In contrast, the Q-Watch is a wrist-mounted, body-anchored interface with direct touch interaction using finger or hand tracking. It prioritizes low interruption and fast input. The VRQT questionnaire board is a far-distance, world-anchored interface, also using pointer-based interaction. It emphasizes familiarity and spatial stability. These are not just 3 arbitrary interfaces. Together they represent highly relevant points in the current design space: body-anchored versus world-anchored, near versus medium versus far distance, and direct touch versus painter-based selection. We evaluated all tools very close to their default configurations, because that reflects how many researchers actually use these systems in practice. We conducted a controlled within-subject user study with 44 participants. After one exclusion, 43 were included in the final analysis. Participants received intensive briefing and completed tutorials. They played through 3 task trials and then responded using each of the 3 in-VR questionnaire tools in a counterbalanced order. For internal validity, we limited the study to a single VR task. We wanted to isolate the effect of the questionnaire interface design, not confound it with multiple task contexts or varying cognitive demands. So, we selected a single, consistent VR task that reliably elicited measurable subjective experiences while keeping experimental control high. The task was a reaction-based, whack-a-mole-style visuomotor game. Participants had to hit appearing alien targets with a correctly colored glove. The task was designed to be fast, game-like, and clearly distinct from the questionnaire interfaces. It also used dynamic difficulty adjustment to keep participants inside a stable engagement corridor and to reset the experiential state between questionnaire conditions. Our participants were fairly comfortable with technology, but most reported no or only rare VR use in the previous year. The sample was fairly representative, with an acceptable gender split. Ages ranged from 19 to 63. Regarding usability, the rover station clearly outperformed the other two interfaces. Usability scores were consistently very high for the station and still fairly good but more divisive for the watch and the board. The model-based analysis showed the station rated significantly higher than both watch and board with very strong Bayesian evidence. There was also an interesting order effect. The board was judged more harshly when it appeared later. That suggests a comparative exposure effect. Once participants had experienced more usable interactions, the board's weaknesses became more salient. In the interviews, participants offered rich feedback on usability and comfort of the different InVR questionnaire interfaces. The station was praised for its forgiving interaction and effective multimodal feedback. Participants liked the overall layout of the board interface, but they struggled with pointing precision, frequent misclicks, and inconsistent feedback. While they felt the feedback of the watch to be limited, the very direct, natural interaction made up for it. Task load tells a similarly strong story with a significant effect and strong Bayesian evidence. Raw score means were consistently low for the station and higher and more spread out for the watch and for the board. In contrast to usability ratings, order effects were insignificant for task load. But the really useful part comes from the subscales in interviews. The board mainly drove up mental demand, frustration, and reduced task control. Participants liked the overall overview of the questions, but were frustrated by the effort required to make selections. The watch mainly drove up physical demand. Participants repeatedly described awkward arm posture, fatigue, and the need to hold the display in uncomfortable positions just to read it clearly. In contrast, many participants mentioned the station's readability, ergonomic adjustability, and how it facilitated fast, effortless reporting. Interestingly, presence and flow showed a different pattern. We did not observe strong systematic degradation of presence simply due to the questionnaire interface. Bayesian analysis showed the high density interval of the posterior within the region of practical equivalence, providing evidence for the absence of a meaningful effect. Flow ratings were consistently high. The relatively low spread suggests a similarly high flow experience across participants as intended by the task selection and dynamically adjusted difficulty. Again, Bayesian analysis supported the null hypothesis, suggesting that experiential measurements remain robust across interface types. Despite the strong usability and workload differences, presence and flow did not meaningfully differ across interfaces. It means that in this tightly controlled setup, interface design changed the experience of answering the questionnaire, but it did not substantially change what participants reported about the task and virtual environment itself. So, what should you take away from this? First, some methodological reassurance. Using InVR questionnaires is not just valid in principle, it's a realistic and defensible way to improve VR study quality. However, study participants are sensitive to interface design choices, and good design becomes a matter of participant comfort and test efficiency. Our findings suggest that for InVRQ interfaces with acceptable usability, measurements of primary experimental measures like flow and presence are robust, independent of interface design. These results should encourage researchers to continue to actively experiment with interaction designs for InVRQs in their studies or to develop updated tooling. However, InVRQ interfaces should be evaluated before used as tooling in studies. This work is also an attempt to lower the barrier to adoption of InVRQ questionnaires. Toolkits like VRQT and Rover are free, documented, and ready to be used by both technical and non-technical research teams. For access, you can follow the links or QR codes. Our hope is not only to contribute to methodological clarity in VR research, but also to empower more researchers from other fields to confidently collect high-quality, subjective data directly inside immersive research environments. Feel free to contact us if you require assistance integrating these tools into your workflow.